Hey everybody, I'm Mr. Rose, and today we're going to continue to talk about current traveling through a wire or different wires in different scenarios. Again, we're going to a more in-depth discussion. So this I have listed as example 2, and then I have example kind of 2A. I'm going to separate them into two different videos, so this is going to be part 1. Now this video, or this example, is just a straight, just a straight, oh goodness, just a straight example of a constant current density traveling through a wire. I want to know, or we want to know, how much current is there flowing between specific portions of the wire from not the center all the way out to R, but from R over 2 all the way out to R. So pretty much the outer half of the wire. That's what we're going to be looking at here. All right, so here you see part of my kitchen table, and on that is the question that we're talking about. Again, this was what was just on the screen. We have a radius of the wire of 2 millimeters, and the current density is uniform of 2 times 10 to the 5th. I'm just hopeful we can see that. 2 times 10 to the 5th amps per meter squared. So we want to know, again, what the current is. What is I through the outer portion of that wire? So if I were to draw my wire, just a blown up version, there, I'm trying to get it on screen. There we go. And that should have been dotted, but sorry. So now this portion, I don't actually care about. I'm kind of gonna X through that, right? I don't care about that. What we're looking for is I am essentially looking for the current in this shaded area of my wire. So what is I in that region? Where here, whoops, to there, that is my difference between R and let's say R over 2. So to do this, it's really just a straight, we know current density J is equal to the current per unit area. And we know that this is just the circle, the cross-sectional area, right? So I know the area is equal to pi r squared. Apple pie, raisins 2. Area is pi r squared. So the area, essentially I want the area of the whole thing minus the area of the inside, right? So the area that the current is traveling through, I can label that AI, would really be the area of the whole thing. That's pi r squared minus the area of just that middle part, pi r over 2, that whole thing squared. In which case now I can rearrange and I can put that straight into there, or I can solve this here. I can say that the area is, I can pull out a pi. That comes out to 9.42 times 10 to the negative 6th meters squared. So that is this blue shaded area. And now it's just plug and chug. I know the current is equal to my current density times my area. Current is equal to 9.42 times 10 to the negative 6th meters squared times the current density of 2.0 times 10 to the 5th amps per meter squared. There we go. My meters squared cancels. And we should get a final answer of 1.88 or 1.9 amps. So the current in that outer portion is 1.9 amps.